Hello all. In this video, we are going to discuss about the pytorch, and we shall even code a CNN project on pytorch. Okay, but before we start the coding on pytorch, first of all, we shall understand how the coding flow will work in the pytorch. Okay, that we shall see. If you understand this flow, that means you understood already 75% of the coding. Okay, let's go. Now just assume our this is the whole flow. Now let me maximize this. Now assume that here our flow starts. Okay, now assume that we do have a data set, and that data set is related to the digits related data set, and that we did a train test split. Okay, then we have separated x train, y train, x test and y test. After completion of this step, we are going to create tensors, separate tensors. We are going to create one tensor for this, we are going to create one tensor for this, we are going to create one tensor for this, we are going to create one tensor for this. After creating those tensors, we are going to push this data. Like in x train will go to one tensor, y train will go to another tensor, x test will go to one tensor, and y test will go to another tensor. Now uh, to which tensor x train has went, that we call it as features. To which tensor we have sent this y train, that we call it as labels. In the same way, x test as well. To which tensor we have sent this x test, that tensor we call it as features. In the same way, to which tensor we have sent this y test, that tensor we call it as labels. Okay, after creating the tensors, the first part is we have created the tensors. Okay, now we are going to create the tensor data. With the help of these two, we will create a tensor data set. Okay, now after creating the tensor data set, with the help of data loader, we are going to load this data set we are going to load, and as well as we are going to do splits. We are going to shuffle the data. The same as well goes over here. Okay, this is the first part. Okay, now let's go to the second part. In the second part, we are going to do the feature extraction. We are going to create the fully connected layer. Then we are going to combine both. Okay, now second part has been completed. Now let's come to the last and final part. In the last and final part, we are going to go inside the epochs, and we are going to set the training mode. Okay, now inside the training mode, we're going to have the batches. Okay, we're going to take the batches. Here we did split, right? Batch wise split. We are going to take all those batches, and we are going to go what we are going to go one by one. Okay, now inside one batch, what we're gonna do, that batch is going to separate both features and the labels. And these features and labels, we are going to move to the device in the sense nothing but either it might be a CPU or GPU. Okay, then later we are going to clear the gradients, then we are going to find the output. Now to next we are going to find the loss, but to the loss we need to combine both the whatever the output we have received and as well as the labels. With the help of this, we are going to receive the loss. Okay, now then later on we are going to do the loss back propagation. Then we are going to do the optimizer, like with the help of Adam, we are going to change the model parameters. Okay, now the same thing, now it will happen even for the evaluation. Right now what we did, that is related to the training mode. Now let's go to the evaluation mode. For the evaluation mode, we are going to take this test x test y test data loader. Okay, this batch we are going to prefer. Okay, in the same way, we will go to one batch. We are going to separate it. We are going to get the separate features and labels. Then we are going to move to the device. Then we're going to get the output. Then at the end, we are going to get the accuracy. Okay, this is what is going to happen now in the coding. Okay, now let's start our coding. I have imported already certain required things. Now first let me add the data set. This data set I am taking from the Keras, but no worries, whatever the rest of the code, that will be in the PyTorch itself. Just this data I have taken from the Keras. Okay, now we have taken the data set. Now let's import certain things. Okay, now let's create our tensor. Okay, to create the tensor, okay, now already we have got the solution that I have taken, but we need to add the data type as well. So now I'm adding data type as like this, and we are going to reshape to the 40 as CNN expects, as it's going to have the batch size, height, width, channels, right? So that's why we have taken 4. Okay, now let's let's add even data type even for the white line labels. Now what we did, we have created the tensor and we have pushed this X train data and as well as Y train data. Okay, now let's run this. There was some spelling mistake, that's why I was getting that issue. Okay, now we have to create the tensor data set. For that, let me create, we are going to create for the train back train data set. Now to create the tensor data set, what we have to do, simple, we have to add this, that's it. We have got the solution, so I have taken that. And let me add now. Now we have created the tensor data set. Now what's the next step? Now we have to do that, data splitting, shuffling, that thing we have to do, right? So for that we need to take this data layer. Okay, now we have got the solution. What we did, we just passed this inside this data loader and we are doing the split. Okay, now okay, now this is the same thing we have to repeat even for the X test and Y test. Let me copy this code. What I will do is I will just add that test. But so we are creating tensors even for the X test, Y test. Now even this has to be created. So let me copy this as well. We are passing this. Okay, now the same way we have to pass this as well. Okay, now we have created tensors for the both X train and Y train, X test, Y test, and we have created their own data sets. Okay, now let me run this. Just please let me recheck that I have copied properly or not. Okay, now everything is fine. Okay, now let me import now certain things. Okay, now comes our CNN part. Okay, now in CNN part, first of all we need to add the sequential API. Okay, Now inside this sequential, we need to add convolutional layers. Now let me add my first layer. Now inside my first layer, I have created this channel filters. I have provided filters, and the kernel size is 3 by 3, and the padding is same. Now let me add the activation function. Okay, now let me add batch normalization. This stabilizes our training. Now let me add another layer. Now we are going to add max pooling. Now over here what we are going to do is we are going to compress the image by remaining the features. Okay, now let me add another convolutional layer. Now let me add activation function. This is a simple, if you already know the CNN, then this will be quicker. Okay, okay, now I'm adding the batch normalization. Now let me add even the pooling layer. Okay, now our feature extraction layer has been completed. Let me name this extraction. Okay, now our feature extraction layer is completed. Now we have to do the fully connected layer. Okay, now for that, when we take this, create a sequential. Now inside this, you add the layers. Okay, now first of all we need to flatten this. Okay, then later we have to add the linear. Now you can take any number of neurons whatever you want, and this is the output that we are receiving from here. I will show you that as well. Okay, now let me add the ReLU function. Now let me add the dropout layer. This will drop randomly some of the neurons. Then let me add one more layer. Okay, now let me add the activation function. Now saying let me add dropout layer, and now let me add the last one. Okay, now our fully connected layer as well has been completed. Now let's name this as okay, let's name it as this. Okay, earlier there was some indentation issue that I have fixed, and I did the GP27. Okay, now let's understand what's exactly bit more in depth. Okay, now first our input shape is this. Okay, this is the part which I'm explaining over here. Okay, now the next which we have taken is this. Okay, now this is like we have taken channel 1 32 filters, and 28 by 28 is our image size. Okay, now in the pooling layer what has happened is this hasn't changed, but coming to the size of the image has been decreased to the 14. Now once again we have added another convolutional layer with the 64 filters. Now we have taken this input size. Okay, this is the size. Now once again what we did the pooling, and once again it has been decreased to the 7,7. So now at the end it has ended 64 7,7. That we have taken over here as our starting. Okay, and as like 150 neurons, you can take as many neurons as you want. It is something like trial and error. Okay, now let's go to the next step. Now let me create the loss function. Okay, now let me add the optimizer. We are going to use Adam. actually, though we have created this, feature extraction layer and fully connected layer, but we haven't combined this, right? We have to combine this. So for that, we are going to do like this. We are going to combine and we are going to create a model. Now, now okay, now let me run this one. Okay. Now we have to move our model to the device. Okay. Currently we are running in the CPU itself. Okay. So now let me push my model to the device. Okay. Okay. Now our main important part of the coding has been completed. Now the last and final step which we are in, that is the training, and the second one is the evaluation. Okay. Now let's start our training. As of now, I'm taking only one epoch, and I need to loop this epoch. Yeah, I'm going to loop. Now we have to set the training. Okay, we have to set the training mode. Now we're gonna set as like this. Okay. Now what we have set, we're gonna use the data loader, right? So we that data loader is okay. In this train loader, we are going to go inside a batch. Now inside a batch, we have to separate both input data and as well as our output data, right? So let me separate those both. Okay, now we have separated. This is like our inputs and this is like our output details. Okay, we have separated it. Now what we have to do, the next thing, we have to move these two to a device. Okay, by that all these things will be in one device itself. Okay, now we have to do the, we have to clear the gradients. This is required that we have to do the back propagation, right? Further this is required. Okay, now let's get the output of the model. Okay, now inside the model what we are doing, we are just passing the inputs. Okay, now let's get the loss. How are we going to get the loss? By measuring the output along with the output levels. Okay, now this is our output and this is our output levels. Okay, that we have passed. Now let's do the backward propagation. After the backward propagation, we just need to add the optimizer. That's it. Okay, this is the whole process of the training. Now let me run this. Okay, now our training has been completed. Now let's go with the evaluation. No, so even for the evaluation, first we need to set the evaluation. Let's add some variables. Okay, now earlier we have added a batch, that means a loader, data loader for this, right? In the same way, for this we have added the train loader. For this we have to add the test loader. Okay, okay, now the same process, like separating the input data, and the input labels. Okay, then that we are passing to the device. Okay, then once again we have to get the output. Okay, now we are going to get the prediction. Here we are going to have the predictor data. Okay, now we are going to get the total size of the all the labels. Okay, now after getting, we need to get the how many are right right predictions. Even that data we have to get it. Okay, what we are doing over here, first of all we are getting the total size of the all the labels, and as well as we are checking how many are right. Okay, now let's print our accuracy score as well. Now let me run this. Okay, it's almost reached at 98. Okay, this is the whole video how we can use the pytorch and work on the CNN. I hope you understood. Thank you for watching this video.